All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about PWM, um, the same thing that we've been doing for the past couple of streams. However, now we are doing things on a much higher level because in the past we have been focusing on how PWM works on a low level, trying to understand basic concepts like clock signals and how the initial clock signal is generated by xtal, which is our external crystal oscillator, and then how that gets multiplied or amplified up to a higher frequency, and then how that clock signal at a higher frequency gets divided down when it's going to be used by various different types of hardware. And we also learned that one such hardware is the APB clock, or well, not hardware. One such signal is the APB clock. One such hardware is the APB. Um, what was the B? I forgot. I think it's bus. So advanced peripheral bus. One such hardware is the APB that uses an APB clock, and the APB clock signal is generally at 80 megahertz. It could vary though, depending on certain factors, but generally it's 80 megahertz. And so, given using that as our base clock, we then do our further calculations for when it comes to PWM frequency, PWM resolution, and other PWM related variables. So we've been busy learning about all of that stuff, and recently we set up our give me a second. Yeah, recently we set up a very simple PWM example, a very simple PWM fading circuit. Actually, I kind of want to set that up again over here. Just give me a second because I'm doing some stuff on another machine. We have this and we have this. Unfortunately, yesterday I didn't get too much time to do Western related studies. I actually got busy doing something else. I can't remember exactly what it was. Um, what did I get busy doing? I was busy with something. I was reading up on something, and yeah, I can't remember too much. But I was busy with something. I unfortunately didn't get a chance to do too much Western related practicing or reading or whatever. Hopefully today. Hopefully today I'll make more progress because I do, now that I've got this ball rolling, I do want to see it through. I want to learn all of the concepts of Western that I've been meaning to learn. More specifically, all of the multiplexing related concepts that I've been meaning to learn. I want to see that through. And of course, we have to continue. Well, this specific one, I am continuing it because I'm not doing it on stream. Actually, I mean, even the Western thing, I'm not doing it on stream. I'm discussing it though on stream, but I'm not doing the actual reading on stream. Um, but give me a second here. I want to flash a new thing on here. Um, yeah, I'll flash the wait. In order to get this to work, because I had set it to 6, right? I can change this back to 5. And oh, you know what? No, I'm going to keep it at 6. I'm going to keep it at 6. Actually, something that I realized yesterday was in terms of, because like I was trying to understand, I was trying to wrap my head around the higher words, the higher level concepts here, because like we've been for quite a while we've been working very much with low level stuff, not too much high level stuff going on. Give me a second. I'm just refreshing the RTMP feed. Okay. All right. So for a while, we have been looking into. We've been trying to understand PWM on a much lower level, and we've been looking at how the hardware behaves, how the hardware treats the various signals that are coming through, how a signal from one piece of hardware morphs into something else as it goes through, different pieces of hardware. Um, yeah, so for a while now, we've been focusing on the low level stuff. Now that we've started doing stuff on the high level, I've kind of lost my mental model of it. I've in fact, I couldn't even this the term mental model. I even got that from Gemini. That's how lost I was in terms of I'd forgotten how I'm supposed to be thinking about this, because when we are doing a lot of this stuff, the whole idea with these microcontrollers and being able to program them and stuff like that, even if you're using a low level language, the whole idea is that you are supposed to be able to um, how do I say this? You shouldn't have to understand how the entire microcontroller's hardware is working. It's great to get an understanding of it, but you don't have to, understand that, oh, there's an Xtal that's producing a clock signal that then goes to the PLL, which then amplifies that signal, and then that gets fed into a mux, and depending on certain, or actually various muxes and various other hardware, and then depending on different variables, or different parameters, the signal is either going to be divided down, or it's just going to pass through, or whatever, right? You don't need to understand how the hardware is working on a lower level. You should be able to just get. You should be able to just uh, words. What am I trying to say? You should just be able to start using the high level features. I needed to go down to the low level because I kind of wanted to get an understanding of how things are working on the low level. You don't have to do that though. In fact, I don't think I'm wrong in assuming that the majority of the people that learn about microcontroller related development, they don't necessarily need to go down to that level. Again, I went down to that level. I think me needing to go down to that level, it was a mix of my curiosity and me getting carried away in terms of low level research, and also me just not um, not knowing how things work, and like that was bothering me. So I wanted to understand all of this stuff. And of course I did get a little carried away with um trying to understand how things work on the low level. Now that we've come back up to the high level, which is, doing stuff in code, I need to kind of reset my mental model of it. And I'd gotten so lost in terms of how I want to be thinking about this, that I had to talk to Gemini, and I had to be like, okay, this is the situation. This is the code that I've written. This is what the case was before. I learned so and so, so and so, so and so. I learned about the Xtal and how the signal is going, it's being generated by the Xtal and then going to the PLL. And from there, it goes to APB. And then the APB clock ends up being 80 megahertz. And it can be different depending on certain circumstances, and all of that stuff is fine. But like now that I'm doing stuff on the higher level, I'm feeling kind of lost, and I don't really know how I'm supposed to be looking at this. How I'm supposed to be looking at this. I It's more like, in order to progress further, I need to reset my mental model of how I should be thinking here. And I should only go down to the low level whenever I need to. I still do want to understand the math going on here. However, I want the why to stop at a certain level. in terms of asking why I'm doing stuff like this, why, let's say within, um, why there's very specific duty resolutions, why we are only able to set. I mean, I understand the why of, you know, why why the frequency can only be between a certain range. Actually, I understand why the highest range is there. I haven't explored yet why the lowest range is there. So I understand that the highest resolution that you can, or the highest frequency that you can set is going to depend on the duty resolution that you have set. So 6 bits gives you a maximum of 64. And that's why if you set it, well, 64 kilohertz, um, so 64,000. That's why if I set it to 65 kilohertz, now it's just stuck in this weird state. I should also explore what this weird state is, because it's like a half on, half off kind of thing. It kind of behaves similar to a floating pin. Um, but yeah, yeah. So I want this to be 64. Um, I also want to explore. Um, I also want to explore how these values are affecting the PWM, and the PWM itself, the signal that's being sent, how exactly things are working on that front in terms of like what I'm looking at, and also just in general what is going on there, even on the lower level. I want to understand what exactly is going on. So if we are saying this is okay, um, we've set a frequency of 64 kilohertz. So that's 64,000 cycles per second. And within these 64,000 cycles, each cycle has, that comes later on actually, here. Within these 64,000 cycles, each cycle has an on state of 10%, and the remaining 9%, 90% is an off state, right? Us having this, so okay, we have this, fine, great. Then we come over here, okay? For now, for the sake of simplicity, I'm gonna disable this or comment out this code and come here and re-upload this code. Okay, so we're only gonna get a fading on effect, and then I guess it just goes off and fades back on again. Um, hold on. Yeah, that's what happens. So what I would like to understand is what exactly is going on here, because we do this thing, start duty fade, and I'm assuming what we are saying is that um we want a fade effect. Hold on, is fade the only function that we have here? Is duty fade running? Start duty fade HW. I should look into what that is as well. Um, configure HW with drive mode. Set duty HW. What is HW supposed to be here? I should find that out. But yeah, it does seem like that's about it. Yeah, yeah. So that's what we are doing with LEDC. There's a start duty fade function. I should, yeah, I do need to look into the HW part of it. Wait, it seems like there's a scrolling option. No, it just says HW, doesn't say more. Okay, um, so we have this function, okay? Within our loop, we have this function. It says start duty fade. This starts a duty fade from from one percentage to another. So we want to fade from 0% to 100%. over the duration of 1 second. That's 1,000 milliseconds. I need to understand what exactly this means. What is happening over here? Um, Small percentage changes, long durations, coarse PWM resolutions, that is low bit counts, and higher frequencies will all be more likely to fail this requirement. Oh, I think I just understood what this is. This is an escape character. This is an escape character. So this is supposed to be um we are shifting. This is a bit shift operation. We are shifting the bits of one by so and so, and then we are multiplying that by the absolute of. That is interesting. And this is supposed to be a condition. This is supposed to be a condition that this is all less than 1024. So we do frequency multiplied by duration. Let's say our frequency is 64. Our duration is in what, milliseconds? So let's say 1000. That words, holy shit. Does. Does it mention yeah, it does say duration is meant to be in milliseconds. So 64,000 multiplied by 1,000, so 64 million. Is that right? Do I have Python open here? No, let's open it up. 64,000 multiplied by 1,000. That is, yeah, that's right. Three zeros, three zeros. So 64 million. Give me a second. I just remembered I was supposed to, first of all, put my phone on charge, but also open up my chat on my phone. So I'm just going to do that. Give me a second. Okay. All right. So, yeah. So 64 million divided by whatever this value is. Start is supposed to be 0, end is supposed to be 100, so that gives us negative 100, and that's why we are doing ABS. Okay, one, mm, we are bit shifting here. I need to hold on. Um, bin 2. Okay, all right. Bit count. Our bit count is 64. No, 6. It's 6 bits. So this and this. So that's our bit count. Otherwise, we would be looking at this value. I don't know if we are able to set like a, hold on, let me see, help bin. Yeah, I don't think we can specify the number of bits. There might be some function that does that, but this specific function doesn't do that. It only mentions as many bits as it needs to. Okay, so we bit shift towards the left by our bit count, and then we are essentially, yeah, what would this be? Um, how many zeros is that? Seven? Six? Seven? I think it's six. Six. Deck is not defined. Maybe int 64. All right. Hold on, dude. I did not know that this is a trick that we could use. This is basically the way of finding out that in given a certain number of bits, what's the max value that you can represent. So, for example, if I want to do, if I want to find out that in 8 bits, what is the max, or in 10 bits, what is the max value that I can represent? I can do int this, this, and then we get 1024. Holy shit, I need to remember that, dude. And that makes sense, doesn't it? Because holy shit, dude, this did not occur to me. Because okay, hold on. This is great. This is amazing. If we look at 0b, um, this would be 16, right? Well, 15. 15. So if we want to know what is the max value that can be represented, well, okay, if we are counting from 0, then it's we are taking like, negative of that, but the maximum number of values that can be represented, the maximum possible, you know possibilities that can be represented, um that is our, 1 bit shifted to that many values, because here we've reached the maximum of 16 bits. Sorry, 4 bits. We've reached the maximum of 4 bits here. And because we are counting from 0, so the max is 15. Generally, it's supposed to be 16 because, you know, but it's 16 possible, different numbers that can be represented within 4 bits. Uh, to get that number, 16, if we just add one more, this is the value that we'll get. So it becomes, instead of 1, 1, 1, 1, if we add 1 to this, 1, 1, 1, 1, we get 1, 0, 0, 0, 0. So that's what's going on here. Basically, that's what they've done. And holy shit, this is a neat trick. I should remember this. This is actually a neat trick, dude. That's crazy. Right. Anyways, so back to where was I reading this? In the code. I was reading this in the code. Um, so all right, there's a constraint on the combination of timer frequency, timer PWM resolution, and fade range. Um, no, not and fade range, the fade range, quote unquote, and the duration. So the constraint is this. The constraint is that whatever that evaluates to, I'm assuming that thing is evaluated last, isn't it? I hope so. Yeah, what's the arithmetic precedence for this? Yeah, no, they're saying that this is a constraint. So, I'm assuming they're giving us a condition, and we are supposed to be getting like a true false answer for this. The only way we're going to get that is through is by evaluating the um, less than symbol last. Now, that being said, what this is saying is that whatever we get, whatever value we get, it has to be less than 1024. Otherwise, it's not going to work. So let's try this, okay? Frequency is 64,000. 64,000 multiplied by 1,000, which is our duration. So the multiplication will happen first. The division will happen later. Okay. I don't know what precedence the bitwise operators have. So I guess it's best to put it into, yeah, yeah, let's do that. So we want to get the max value. Our bit count currently is 6. Okay, and we are multiplying that by basically 100. So 0 minus this. Okay, all right, great. So this will evaluate first. This will be multiplied by 100. Um, this is going to be 64. It gets multiplied by 100. That's 64. That's 6,400, which then gets divided by 64 million. Okay, that's confusing. Did I miss something? I feel like I missed something. 64,000 is our frequency. Our duration is 1,000. Okay, bit count. All right, multiplied by so and so. Okay, we know the value here, so let's just put this in. It's still the same. We know this value also, so let's simplify. Wait, hold on, hold on. I just remembered. Yes, okay. This is a Python related issue. Well, I mean, okay, this is a Python related issue. Oh, it's doing the multiplication first. So, hold on. So we need to do this, but then we also need to do this. I think I remember this from the last time that we had faced this issue. Damn. It did not make a difference. What was the issue that we faced the last time? Did we find out that it does the multiplication second and then the division? Because if we are following PEMDAS, then it's going to be parentheses, exponents, multiplication, division, and then, addition, subtraction. But multiplication is supposed to happen first. Um, yeah, why is this saying 10,000? Because 10,000 is not less than 1024. It's definitely more. So, like, what's going on here? So this is, there's a constraint on the combination of timer frequency, timer PWM duty resolution. Okay, timer frequency. Timer frequency. Okay, we are setting a timer frequency. That is our 64,000, isn't it? That wouldn't be the 80 million, I'm assuming. Yeah, I don't think that would be 80 million. Okay, the fade range and the duration. Duration is also mentioned here. Okay. Small percentage changes, long durations, course so and so, so and so, so and so. And higher frequencies will all be more likely to fail this requirement. Yeah, I'm a bit confused here because Okay, let's see if there's like any docs that I can look up for okay, ESP32, no STD Rust, start underscore duty underscore fade. Okay, 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 all right, we'll go into ESP HAL. I'm assuming that's where it is. Yeah, it's under ESP HAL, under timer, I guess. No, it's under channel. Channel, iFace, okay. Low speed channel, high speed channel. This is a channel. All right. Okay. In here, I'm gonna try and search for start underscore duty underscore fade. All right. Start a duty fade. This is under channel, and then there's the module is just defining it. All I have here is the code to look at. Oh, wait. This is the trait being defined, not the implementation. Where can I find the implementation for this? Okay, let me try searching here. Start, duty, fade. Okay. Um, is this where it's being done? Yeah, impl channel iFace for channel. Yeah, here it is. Okay. Have they mentioned it in the docs over here? Actually, no, wait, they might have mentioned this previously in like comments or something. No, it just says, yeah, no. Oh, here it is. And even here it says that, okay, where's the requirement being enforced here? Duty per cycle, okay, self dot so and so. Okay, I'm gonna need some time to read this and understand it because there's a bunch of things going on within this code. I haven't fully understood what um what possible problem we could run into here. Because it says, okay, there's a constraint on the combination of timer. Um, there's a constraint on the combination of timer frequency, timer PWM duty resolution, the fade range, and the duration. Okay, all right. Now I did the calculation, and based on the calculation, we fail this requirement. So how is it working then? I feel like I need to copy this. Give me a second. I hope this yanks it properly. Right. Let's open up a new conversation with Gemini. Hey, help me understand this documentation for channel dot start duty fade in ESP32, no STD, Rust, ESP HAL. Um, Specifically, I'm confused about the quote unquote constraint because I did the calculation with a frequency of 64 kilohertz, um, duty res of 6 bits, and wait, duration 1000 milliseconds, start 0 and end 100. My result came up to, uh, was it 10,000? Yeah, which is definitely less than 1024. So how is my code working? Okay, it sounds like you run it into the classic order of operations or units trap that often pops up in embedded documentation. It's a bit ironic that the documentation warns you about high frequencies and long durations, making things more likely to fail, while your calculation suggests the opposite. The reason your code is working and your calculation is hitting 10,000 is a slight misunderstanding of how inequality is structured or how the units are being applied. The math check, let's look at your variables. Frequency is 64,000 hertz. Duration is 1000 milliseconds or 1 second. Resolution is 2 to the power 6 or 64. Yeah, yeah, that's what we said. So 1 bit shift 6. Um, then range is 100. All right. If we plug these into the formula provided in the docs, it is f multiplied by d divided by um, 64 multiplied by, what is r supposed to be? R is the range. Yeah, yeah, we did that. We did that. Using your numbers, hold on. 10 is much lesser than, okay, so your configuration is perfectly safe. 10, okay, what they're doing here is that they've converted the duration from milliseconds to seconds, and that's why it looks like that. So, keeping that in mind, um, this is what they did, and that comes up to 10. Okay, 10 is much less than 1024, so your configuration is perfectly safe. Why did you get 10,000? It looks like you might have multiplied by the duration in milliseconds. I thought that's what I was supposed to do. I got the units mixed up. That is why. Okay, okay. 1000 rather than 1 second while keeping the frequency in hertz. Oh, I didn't take that into account. I'm expressing the well, to be fair, I wouldn't have thought that they were trying to express the I wouldn't have thought that they were trying to express the duration in seconds because in the function I specified it as milliseconds. So in my defense, was it mentioned? Did I miss it in the docs somewhere? Maybe it was mentioned here because it just says duration. It doesn't say duration in seconds. Yeah, yeah. Okay. Maybe I should suggest this as a tiny change. I should suggest this as a small change because this can be confusing. Pretty sure it'll be confusing for other people as well, especially because if you look at the function definition here, actually, am I able to apply the yeah, okay, can't do that here. No, wait. Argument. Can't do that here. I can do that here though. Yeah, I can like jump arguments. Um, can't do that in the documentation though, which is fine. I am trying to, yeah, so if you look here, it says duration in milliseconds, and apart from that, it doesn't show like any other units. But then in the documentation here, it mentions duration. So if you have previously looked at the duration in milliseconds and then it says duration here, you're probably going to assume that it's it's in milliseconds. Yeah, I think I should suggest a change to this. Let me write this down so later on I can go and suggest it. Uh, Post stream, GitHub, start duty fade docs. What did I just write there? Codex docs 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 duration unit confusion. Okay, right. So okay, what does that tell us? Does that tell us that we can only have 10 bits of resolution? Are we able to set anything more than 10 for our resolution here? Let's try that. Let's yeah, we have something higher. So let's go for 11 bits. What is the max with 11 bits? Um, okay, 2048. So we're gonna set that as our thing and see if this works. I'm hoping that if we set it to a value that causes some sort of error, then it's going to report back the error. It is just not working. Yeah, it just didn't say anything. Yeah, no. Um, let's go back to this. Okay, so it works, but then anything above that, it just doesn't respond. So what is this saying? So that's our constraint. Our constraint is 10 bits. Now let me see what Gemini is saying about this. Okay, okay, all right. I'm glad that Gemini mentioned this. Why the constraint even exists? The ESP32 hardware uses a fading step register. Essentially, the hardware needs to decide how many time cycles to wait before it increments or decrements the duty cycle by one step. The problem, the internal hardware counter for these steps is usually 10 bits wide. The result, if your frequency is very high and your duration is very long, the hardware will need to wait more than 1024 cycles between each duty cycle change. If the required, wait, they say duty cycle. Do they mean the entire cycle or just the duration that the duration of the cycle that it is on for? Because this terminology gets a little confusing when they are using it interchangeably, if it's being used interchangeably. I'm assuming because, like, okay, if we say duty cycle, at least from what I've seen in the past, when they say duty cycle, um, they mean the percentage of time that the percentage of the cycle that the signal is on, the signal is high, and the remaining percentage is low. So the percentage that it's high is what they consider the duty cycle. But are they calling the entire thing the duty cycle now? Because that would kind of change things. Wait, hey, so just for clarification, when you say duty cycle, do you mean the entire cycle, both on and off states, or just the percentage of the cycle that the signal is on for? Oh shit, we are dropping frames. We are dropping frames big time. Give me a second here. I'm going to do what I can to hopefully stabilize the connection. Okay, I think we are good. Okay, great question. In the context of PWM, duty cycle specifically refers to the percentage of um, the time cycle, refers to the percentage of time the signal is on or high, is the signal is in the on or high state during one complete cycle. The quote unquote entire cycle, which is the on plus off time, is called the period. Okay. Okay. So then in this context, when we say duty cycle, the duty cycle has to be, so the duty cycle has to be greater than 1024. And the duty cycle is able to be greater than 1024 here because we've set it to 10. We haven't specified the duty percentage in this, what do you call it? In this algorithm, in this equation. We haven't specified what duty percentage we set. The duty percentage changes based on, actually it would change on, it would change based on a bunch of things, but is it the duty percentage that we are talking about? Let's go back and read that. Uh, there's a constraint on the combination, and okay, this is the constraint. It should come down to that. And let's go back to Gemini's reasoning for this. Gemini is saying the ESP32 hardware uses a fading step, quote unquote, fading step register. Um, Essentially, the hardware needs to decide how many timer cycles to wait before it increments or decrements the duty cycle by one step. How many timer cycles it needs to wait before incrementing the duty cycle by one step. No, I need to understand this. I need to understand this. I don't think I fully get this. Sorry, zoned out. Okay, the internal hardware counter for these steps is usually 10 bits. If your frequency is very high and your duration is very long, the hardware will have to wait more than 1024 cycles before each duty cycle change. It would have to wait more than 1024 cycles before each duty cycle change. What does duty cycle change mean here? Okay, duty cycle is a ratio or percentage of that period. If you have a 10% duty cycle, our period is, what is our period? Because we have 64,000 cycles in 1 second. So how are we like setting this up? Would it be 64,000 or 1 divided by 64,000? Is that what gives us our no, I'm not sure. What was it? 10F, I think. Yeah, I think it was 10F. Maybe I can um let's do it like this. 1.5625E05 um dot 10F. Did I do that right? I did. Okay. How many nanoseconds or milliseconds is this? What was I even trying to do here? I forgot what I was trying to do. Because like within a second, we have 64,000 cycles. Those 64,000 cycles, each cycle in that has a 10% duty, has a 10% duty cycle. I'm not sure how to say that. The duty cycle for each period is 10%. The duty cycle for each, so we have 64,000 cycles. We have set a duty, um, we have 64,000 cycles. We've set a duty resolution of 6 bits. So that gives us, does that give us 1024? It gives us 64. 64 divided by 64,000. Okay, 64,000 divided by 64, 1,000. Does that mean that we have, does that mean that each cycle is, each cycle is 1,000 ticks? And then, yeah, if each cycle is 1,000 ticks, 10% of that, which is what we set here. Yeah, duty percentage is 10. Shouldn't that be 100? Yeah, I think 10% of that should be 100. I'm confusing something here. I need to sit down and think about this. Okay, so the period, that's our total. Okay, so that's the total time it takes for the signal to complete one full cycle. That's the total time it takes for the signal to complete one full cycle. So that's one period. Okay, okay, I get that. I get that. Then the duty cycle is the ratio or percentage of that period. So if we take 10% would be 0.1, right? So if we do, oh God, that becomes a tiny value because already if we are doing this, we have a tiny value, right? And then if we multiply that by 0.1, that's an even more tiny value. What are we trying to look at here? A ratio or percentage of that period. If you have a 10% duty cycle, the signal is high for 10% of the time and low for the remaining 90%. Okay, why it matters for your fade? When you call start so and so, you are telling the ESP32 start, keep the signal on for 0% of the period, and gradually increase on time until it stays on for 100%. Wait, gradually increase that on time, gradually increase that on time until it stays on for 100% of the period. How are you doing that? Like gradually increase. Oh, we are gradually increasing for like I feel like I'm confusing the grammar here as well. Hold on, I need to sit down and think about this. I need to sit down and think about this. Transition spread that increase out over 1000 milliseconds. The hardware is essentially recalculating the width of the on pulse for every cycle until it reaches your target percentage. Dude, I'm wondering if I should be trying to get the math down for this in terms of ticks or not, or if I should just stick to whatever high level calculations we are doing and not complicate things for myself all that much. No, I need to spend some time doing some research on this. However, I also need to end the stream here because I have some food preparation to do. I've been slow cooking some basically a lamb curry kind of thing. I was experimenting with slow cooking specifically because for a while now I've been trying to understand the concept of slow cooking. Like, do we need to slow? It's called slow cooking, right? But then somehow it didn't click for me whether I should keep the flame high or low. It turns out high is what ruins it, and low is what gives you that nice melt in your mouth kind of texture where the meat is just falling apart, but you still have like this, well, and not but. So the meat is kind of, it's incredibly tender and it's falling apart. And this is red meat we are talking about. Meat that it can go tough really quick. In my case, though, I'm not doing like steak and stuff. It's a curry, so it's already like marinating in juices and stuff. It's not going to become super dry. However, I wanted to get that very gelatinous kind of texture, and I managed to get that today. So my curry is almost done. I'm gonna go finish preparing that. That's why I need to end the stream a little bit early today. We've streamed for only an hour, but that's okay. I'm gonna stream again tomorrow, and then we're gonna continue with this. I need to even off stream. I think I'm gonna continue trying to understand what's going on here because there's a lot in terms of calculations that I need to do to understand what is going on here. I have to wrap my head around this before we proceed with this, before we proceed further. Otherwise, I'm not going to be satisfied. Um, so yeah, I'm gonna do that off stream so that on stream we can make some more progress. But that being said, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.